Let's see now. So this is very important chapter. Surely 6 marks will come. Surely 6 mark will come. Okay, there is one special topic. If you want to divide this chapter, you can divide it into two parts. One is fully related to the current resistance cells. The other one, Kirchhoff law. Okay, 100% a question will come from that topic. So out of the six, you can give 3 marks for the topic, 3 marks for this topic. Clear? So in today's class, what is our main aim is we want to study current, about the current, and we know electrons will move inside the conductor, right? At what velocity they will move, that we will study in today's class. And what is the relation between that velocity and the current, we will study. Clear that thing now? So what we are going to study in today's class, we are going to study only at what velocity the electrons will be moving. That is one point we are going to study. And what is the relation between that velocity and current, that's what we are going to learn. Clear that thing now? Suppose if I take any conductor, let's see the some introduction, then we will enter. Okay, what in last chapter you studied, tell me? In last chapter you studied charges at stationary, means charges at rest. Yes or no? That's what only you studied, right? Whenever charges started moving, they will create current. The current will be produced. Understand? What is the required phenomena? Tell me. Charge should move. That's it. If charge is moving, you will get the current. Clear that thing? If charge is moving, you will get the current. One of that phenomena is this lightning. Lightning will be there, right? During that lightning, so much of charges will transfer to the earth. So that will constitute current. Very dangerous. Understand, that will constitute the current, very dangerous. So that's what I mentioned there. Lightning is one of that phenomena in which charges will flow. In which charges will flow from where to where? Clouds to the earth. Clear that thing now? And remember, the flow of charge may be steady or may be unsteady. What do you mean by unsteady? Means from the clouds, whatever is coming, that will come, that may increase, that may decrease. It cannot be a fixed number. It's not a constant value. For example, in a river, normal time water, how smoothly it will go? A particular amount of water will go in a proper manner, very beautiful it will be there. That is a study. Whenever floods is coming, that will be, amount will be different, right? So that will consider as like a unsteady. So the same way, if a particular amount of current is flowing, we will tell it as like a steady current. If not particular amount, some variable amount if it is happening, we will tell it as like a unsteady current. Clear that thing now? Fine. Now here, whatever we are going to study, that is going to be a steady flow only. We are not at all going to touch unsteady. Understand? And in this chapter we will develop some basic laws, okay, related to this electric currents. We will develop some basic laws related to this electric current calculations. Understand this? So you got the clarity. What clarity you got means, okay, charges should move, current appada varum. Yes or no? Okay, current may be steady, means exactly proper value, or it may increase decrease like that value, that is unsteady current we can. That's it, right? You understood in the introduction. Let's see the next. Let's see electric current. What is electric current? You studied electric current, about electric current in your 10th class itself. What you studied there? Rate of flow of charges is nothing but the electric current, you said, right? The same definition only everywhere. What is the definition for electric current? The rate of flow of charges. That is Q by T. What is that? Q by T. I is equal to Q by T. Suppose if that rate is changing, means if suppose same amount of Q is changing, that is comes under steady current. Means I kept one gate. Every second if I see 3 people are passing through the gate. So that is comes under steady. Sometimes 3 people, sometimes 4 people, sometimes 7 people, sometimes 1 people, sometimes 100 people, like that they are going, means that comes under unsteady case. In unsteady case, we would like to measure instantaneous current. What do you want to measure? Instantaneous current. Instantaneous current is given by dq by dt. They will give q as a function of time. You have to differentiate the q. So what they will give? They will mention this q as a function of time. They will mention it as a function of time. Understand? They will mention this as a function of time. We need to differentiate it to get the instantaneous current. Is that clear for everybody? Yes or no? So what is the definition of current means? Rate of flow of charge through any cross section of a conductor is called electric current. Electric current. Fine. Next. So what are the SI units of electric current? SI units of electric current. What is that? Ampere. Okay, what is the SI unit of electric current? Ampere. Now see here, if I want to save 1 ampere, what is the formula we are having? Tell me. I is equal to Q by T, right? I want I as 1 ampere. Okay, 1 ampere. That is nothing but Q should be what? 1 coulomb. T should be what? 1 second. Oh, if 1 coulomb charge is flowing for 1 second, then how much current is passing through that conductor? 1 ampere. Are you clear with that? What is that clear point there? When 1 coulomb charge is flowing for 1 second, how much current it is going? 1 ampere current is going through that circuit, through that conductor we will tell. Are you clear with that? Yes. Now see, ampere is a, normally in our home it will come 1 amps, 2 amps, 3 amps, 5 amps current. When cloud we stop at lightning, how much ampere it will be, you know? Thousands. Very, very big power. Understand? So that's what I mentioned. Lightning carries tens of thousands of ampere. 10,000. Clear? And in our nerve also, you studied in your 10th class, some pulses will be there and all. So what is that value means? Microampere. Microampere. Is that clear? Actually, they will do this kind of thing, right? When for emergency purpose, how much current they will put in amps or thousands of amps or let's you know exact number. So it should be less than amps only, because 1 amp is more than sufficient to kill itself. So we should not go to that much. Understand? Because if you get a shock from the house also, people are died, right? Many people. Yes or no? Fine. Let's see the next part. I hope it is clear, right? What you have learned till now? Definition of electric current and its SI units. That's it. SI another one you didn't learn. Very good. Next, electric current in conductors we are going to study. Electric current in conductors. Electric current in conductors. See now. Whenever you place, listen, whenever we place some charges inside the electric field, that charge will experience the force because of the electric field, right? When it experiences the force, then what it will happen? It will start moving. Yes or no? But if the charge is presented inside the insulator, nothing for me. Jolly. You understand? They will not move. That's why they were insulators. Are you clear with that? See that insulator. In some materials, electrons will still bond. They will not accelerate even if an electric field is applied. Those are called insulators. Sir, when force is there, what will happen? They will start accelerating. That's what only charge will feel, right? Because force will be applied. Who is going to apply the force? Electric field. What is the force on that charge? EQ. Yes, sir, we all know this all. If electric field is E, charge is Q, what is the force it is facing? EQ. Because of the force, there will be acceleration, right? Because of the force, there will be acceleration. But what they are telling, in insulators, you will be having the charges, but they will be bound there. They will not accelerate, even though. That's what. If I take one insulator, if I connect it to battery, any current will pass through that. No, they were not moving. Is that clear? But whereas in conductors means not only metals. Conductor means many things are there. Yes or no? Whereas metals, let me take in other metals, not other materials like metals, some of the electrons are practically free to move within the bulk material. They develop electric current in them when an electric field is applied. Those things are called conductors. They will ask, define conductor. What will you tell? When we place the material inside the electric field, the electrons will start accelerating. Hence, they will start conducting the current. Those materials are called conductors. What materials are conductors? Tell me. And the material edith electric field pota, what should happen? These electrons should start moving and should conduct the electricity. Yaar and the electricity conduct panna pora, those are called conductors. Clear that thing now? Those are called conductors. So see, if we consider solid conductors, then which are the charge carriers there in solid conductors? In solids, who are the charge carriers? Electrons. Keep that in mind. Who are they? Electrons. Understand? Who are they? Electrons. Fine. Now let's see now. In solid conductors, current is carried by negatively charged electrons. Correct, right? True, that is. Conductors like electrolytic solution. You will study in your 12th chemistry. Okay. There is one particular chapter based upon cells. Electrolytic cell, two types of cells will be there. You will use some solution there. In that solution, there will be two kind of ions will be there, both positive ions and negative ions. That movement will constitute the current. Okay. In solids are nothing but metals. Who are the current carriers? Verum electrons. But in some electrolytic solutions, who are the current carriers? Positive charges as well as negative charges. Positive charges as well as, you should not tell charges, they should be called as like ions. Positive ions as well as negative ions. Clear that thing now? Yes or no? Yes. But our focus will be on what in this chapter? Only solid conductor. Our focus will be only on the solid conductors. We will not touch these electrolytic solutions or anything. Is that clear for everybody? Purinjicha till now? Clear? What we defined in this slide, tell me? About insulator and conductor we said. So about insulator, what you said, they can ask MCQ question on this. When you place one second. Hello? Not okay. Okay, do you understand what I am talking? Insulator, what question they can make means, if insulator is kept inside the electric field, there are some charges inside that because of the electric field, do they accelerate or not? No, right? True, right? It is. Yes, sir. If they accelerate, they will become conductors. Clear that thing now? Fine. Next. Now, inside the solid conductor, we are going to see. Okay, inside the solid conductor, we are going to see. Now, see. What is the situation? Means, remember, inside the solid conductor, for example, let me take one solid, one metal vechkonga. Suppose I am taking this metal. You just imagine this is a metal. Okay, idukku ulla this metal is made up of some copper vechkonga, copper metal. Idukku ulla nariya atoms irukka? Yes or no? Nariya atoms irukka? Ella atoms lo electrons irukum, right? Yes or no? Outermost electrons will be there, right? Actually, these outermost electrons, since every copper is bonded very very close to each other. What do you mean by that? Means, for example, you people as a students, I am telling, one copper, one copper, one copper, everybody copper. This copper atom will have outermost electrons. This copper will have outermost electrons. What is there in our mind? That outermost electrons are rotating around this. That outermost electrons are rotating in the second copper. Like that. But when it is packed so tightly, these one not only rotating around that, they will rotate freely in the full solid. So in the full solid, the electrons will be rotating. The electrons will be moving. These electrons are belongs to all the atoms. Are you getting? The electrons will not rotate just alone around that atom. That electrons will start rotating everywhere. Sir, but when electron is moving, or sir, not rotating, moving. Okay, don't use the word rotating. Cut that. Rotating na everybody. They are moving. Understand? They are moving everywhere in the conductor. Who are moving everywhere in the conductor? Electrons. Those electrons are belongs to which one? Not this, not this. All. Clear that thing now. When electron is moving, current should be there. You said right, sir. Appa idhula current irukka ipa ipdi hold panna. Illa. There is no current. Why? Because when these are moving, correct, some of them will move in one direction, some of them will move in some other direction, such that net current will be zero. So when you take any metal, adukku ulla electrons will do random motion, true, but they will result net current as zero. They will result net current as zero. I hope everybody clear with that word. Yes or no? That's what we mentioned. When no electric field is present, the electrons will be moving due to thermal motion. What is the reason for that electrons motion? Thermal motion. Because different temperature in the different way they will move. If you make it more hot, more speed they will move. You can observe that in water. Water, when it is started boiling, the water particle will start moving up and down, right? Yes or no? Have you ever observed they will boil? Boiling water pathitara? Yes or no? Fine. Now, what you have mentioned? Due to thermal motion, the movement is random such that net electric current is zero. Is this point is clear? Deepesh, are you clear with this? What I said, tell me. If a conductor is not placed in any electric current, adukku ulla net electric current evalu zero. Net electric current evalu zero. Sir, you can ask, electrons are moving na, current edukku illa? Adi electrons are moving, true, 100%, but they will cancel out. They will cancel out and it will become zero. So you see that on the average, the number of electrons traveling in any direction will be equal to the number of electrons traveling in opposite direction. So there will be no net electric current. That is the reason. What is the reason? Tell me. ஒரு direction எவ்வளவு travel ஆகுறதோ அதுக்கு opposite direction same number of electrons are traveling. That's why net current will be zero. That's why net current will be zero. This is what happening inside the conductor. Okay, if I place the same conductor inside the electric field, what will happen? Yes, they will start moving. Clear for everybody? Now see. Now what we are doing? We have to place that. What we have to place? Conductor inside the electric. Okay, I got that doubt. How do you apply the electric field to the conductor? Nothing. Take this conductor, you keep one positive plate here, you keep another negative plate here, positive plate, negative plate, positive plate, negative plate. Electric field will be created from positive plate to negative plate. So this is the direction of electric field. Am I correct or not? From camera to this end, electric field is there. Why? Because here positive charge, here negative charge. Correct? Positive charge, negative charge. Understood, right? Now observe carefully. Since positive charge is there, negative charge is there, electric field created. In the conductor உள்ள யார் இருக்கும்? Electrons இருக்கும். Because positive charges inside the metal, we will fix it as they are bounded. They will not move. The only person moving inside a conductor are what? Electrons. These electrons only will start moving. Clear? They will move and they will reach what? Positive plate. Yes or no? Electric field, what will happen eventually? It will start decreasing now because the positive value you are suppressing. So it will stop conducting the current. After some time it will be end. Up to what time it will be conducted? Tell me. Up to it get neutralized. It is not a continuous flow. It will get stopped. சார் இல்லை சார் இப்போ இது நான் கண்டினியூஸாக பண்ணணும் அப்போ என்ன பண்ணணும் புரிஞ்சிச்சா கொஸ்டின் நான் என்ன கேட்குறேன் இங்கே பாசிட்டிவ் சார்ஜ் இருக்குது இங்கே நெகட்டிவ் சார்ஜ் இருக்குது கரெக்டுமா இந்த பாசிட்டிவ் சார்ஜ் கம்மி ஆகிட்டே இருக்கு பட் ஐ வாண்ட் டு மெயின்டைன் சேம் ஸ்டடி அப்போ என்ன பண்ணணும் டு மெயின்டைன் த சேம் ஸ்டடி எவ்வளோ கம்மி ஆகுறது அவ்வளோ சப்ளை பண்ணுங்க சார் எஸ் சார் எவ்வளோ கம்மி ஆகுறது அவ்வளோ சப்ளை பண்ணுங்க தென் யூ கேன் கேரி ஆன் ஓ அப்ப எப்படி சப்ளை பண்ணணும் அனுப்பணுமா எப்படி இல்ல we will use one instrument that is only cell or battery that will supply this. Is that clear for everybody? Are you clear with that? Let's see now what I have mentioned. So what I have mentioned there, charges plus q minus q put at the ends of the metallic cylinder. The electric field created is directed from positive to negative, clarity, right? Yes or no? The electrons will be accelerated due to the electric field towards the plus q. They will thus move to neutralize the charges. As long as they are moving, will constitute an electric current, right? True, right? That is also. But there will be current for a very short while. The current is for very short while because charges were neutralized. The charges were neutralized. Understand everybody? Let's see the next. How to create continuous flow of current? Just now we said, right? You put one cell, sir. Illana you put one battery, sir. Clear that thing now? Fine. Imagine a mechanism where the ends of the cylinder are supplied with fresh charges to make up for any change, any charges neutralized. That's what we said, right? Any of the charge, எவ்வளவு கம்மி ஆயிட்டே இருக்கு இல்லைன்னா எவ்வளவு நியூட்ரலைஸ் ஆயிட்டே இருக்கோ that much of charge you have to supply. You have to supply same amount of the charge. Correct? In that case, there will be a steady electric current in the body of the conductor. True. Yes, this will result in a continuous current rather than a current for a short period. True, that is also. Mechanisms which maintain steady electric field are cells or batteries. Son, true, read that sentence also. Next, we will study the steady current that results from a steady electric field in conductors. So now our target, we are entering into the main. Till now, it is for your understanding. Clear? Do they ask any questions from whatever you understood? No, they will not ask. But aditadu, if you want to understand now, you need to know this. You can skip this kind of theory also. We can go directly into the drift velocity. That is only the first step. Clear? But you need to know this. Otherwise, you will get doubt why these electrons are moving. Clear? why this cell is coming into picture. Those all stuff will make you, and so that you will not able to answer the questions properly. Clear now? Clarity came, red conductor, how they will behave when you keep them in electric field. Yes or no? And you got the clarity now. Now we are going to talk about the study flow of the electric current. Okay. So that means what I am using for the steady flow of the electric current, I am connecting it to a battery or cell. That's what only we will do. Am I correct or not? Let's see now. The direction of flow of charges gives the direction of conventional current. See, what is the direction of current means? What will you tell? Direction of flow of charges. முன்னாடி சார்ஜஸ் அண்ணா என்ன எடுத்தார் வெறும் பாசிட்டிவ் சார்ஜஸ் மாதிரி they don't know that negative charges அப்படி they kept direction of current எப்படின்னா அந்த சார்ஜஸ் எந்த டைரக்ஷன்ல போகும் அந்த டைரக்ஷன்ல தான் current. In which direction charges will move, that direction only the current they said. But afterwards they come to know that electrons are moving this way. Should I put the current direction this way? No, you don't change. You will change the sentence. What sentence they changed? Current direction will be opposite to the direction of the motion of the electrons they change. Current direction will be opposite to the direction of the motion of the electrons. If electrons are moving from one end to another end, current will be opposite to that. Is that clear? Direction of current will be opposite. Now see now. Electrons will move always from negative terminal of the battery to the positive terminal of the battery. But current is always indicated from positive terminal to the negative terminal. Always indicated from positive terminal to the negative terminal. Clear for everybody? Fine. Next. Sir, you said current is a scalar. Right somewhere? Current is a scalar. Yes or no? Yes or no? Remember it. Current is a scalar. But why are you talking about direction of electric current and all? Yes or no? When it is a scalar, what's the need of direction? What's the need of direction? Right? That though the electric current represents right, current is a scalar quantity, right? You have written, right? Though the electric current represents the direction of flow of positive charge, though the electric current represents the direction of flow of positive charge, yet it treated as scalar because current follows the law of scalar addition, and not the law of vector addition, and we will see some other place also current is a scalar. Okay, we will get one special quantity, current density, there we will see that. Okay, let's see the next one now. Okay, you can observe here, see here, this is the potential, nothing but the cell, right? This is positive terminal, correct? And this is negative terminal. Yes or no? So the current is moving in this direction, positive terminal. Yes, observe that electrons are in this direction. The motion of electrons are in this direction. See, after some time you will change this diagram. You will find that the electrons are moving like, as of now you are seeing electrons are moving like this, right? In reality electrons will not move this way. Okay, we will see it clearly. Okay, but they will move in this way only. Their ultimate is going from negative to positive. That is true every time. Okay, The path only we will see. Clear for everybody? Yes or no? So this is the direction of the current. This is the direction of the flow of the electrons. Understand? Fine. Now see the next. You said electrons are moving, right? Yes or no? So electrons are moving. One special thing is going to happen here. Sir, electrons are facing some electric field, right? Because of that electric field only, they are experiencing the force, right? When they experience the force, they will get acceleration, right? When acceleration is there, their velocity should change, right? Am I correct or not? This all should happen. See, interlinked everything. Interlinked. What is interlinked? Tell me. Repeat along with me. When you place the electron inside the conductor, so inside the electric field, it will experience the force. That force is responsible to acceleration. Because of that acceleration, its velocity should increase, right? Yes, but here the electrons will not move with a continuous increment in velocity. Electrons will move with a constant velocity. How it is happening? They are facing acceleration, right? They are facing acceleration or not? When acceleration is there, our mechanics is telling what it is telling. Velocity should increase, but how they are maintaining constant velocity? How they are maintaining constant velocity? See, the reason behind this is we know when electrons are moving inside the conductors, they will move randomly. Correct, right? While they are moving, they will come and collide with some of the electrons or some of the atoms inside that, right, that we studied from our childhood itself. Electrons will move randomly inside the conductors, they will collide. While they are accelerating, they will collide, right? When they collide, they will get some kind of force on them, right? That force is such that it will cancel out the acceleration effect. That force is such that it will cancel out the acceleration effect. Which force is cancelling out which force? While they are moving randomly, they will collide. That force on the electrons will cancel out the acceleration effect. Okay, they will not continuously accelerate. They will go with a constant velocity. That constant velocity is known as drift velocity. This way of going constantly with some velocity is known as drifting. Is known as drifting. Is that clear? The sentence are clear, right? Let's see now. The electrons move with an average velocity. See this, with an average velocity or velocity which is independent of time. Although electrons are accelerated. See, although they are accelerated, when accelerated means as time passes, its velocity should increase. But still, they will be having a average velocity. Okay, actually I cannot find individually ஒரு எலக்ட்ரானோட velocity நான் கண்டுபிடிக்க முடியாது. ஒரு எலக்ட்ரானோட velocity எவ்வளவு நான் சொல்ல முடியாது. அதுக்காக we will do average velocity only. So, okay, எல்லாருக்கும் இவர velocity இருக்கு. Like that we will tell. All the time we will talk in terms of average values only. Understand? So, the average velocity is going to be constant. It won't change with the time. Even though it is under acceleration. Yes or no? Even though it is under acceleration. This phenomena is known as drift. This phenomena is known as drift. Clear for everybody? What is that average velocity is known as drift velocity. That average velocity எது சொன்னா right constant இருக்கும் அப்படி that is known as drift velocity. Is that clear for everybody? But in our mind question வருது right acceleration இருக்கு. Yes or no? ஏன் அது velocity increase ஆக மாட்டேங்க? So the reason is that all. Clear? Let's see that reason. Electrons exhibit a constant average drift velocity even while accelerating due to an electric field. And accelerating எதுக்கு வருது? Because of the electric field only, right? வருது. because their constant acceleration is, this is very important, their constant acceleration is countered by the constant average force of collisions with the atoms in the conductor. These collisions results in random changes in the electron's velocity, effectively cancelling out their net acceleration, leading to steady drift. Is that clear? So what is the reason? Tell me. The collision force. Understand? Cancelling out the acceleration. The collision force is cancelling out the acceleration effect. The collision force cancelling out the acceleration effect. That's why it is traveling with constant velocity. That's why it is traveling with constant velocity. Is that clear for everybody? Yes. Yes. Fine. Let's see the next. Now observe clearly this diagram. I'll share you the slides. Okay. Now observe here. Very important thing we are coming into. Now see. There are 2 points in the picture. See the picture. How many points are there? Sir, 3 points are A, B, B dash அப்படி இருக்கு. Picture மட்டும் பாருங்க. Blue color line, dotted line அந்த picture. A கிட்ட இப்ப electron இருக்கு. Where is the electron now? A. I didn't apply any electric field. It will take the path in that blue line. It will see A to B போனும் அது. எங்க போனும்? A to B it should go. How it is going? Going like that, and கடைசில it reached the B. Yes or no? That's what we said, it will do random motion. And it reached to the B. The same electron, if I keep inside the electric field, it is following the dotted path. It is following the dotted path. What happened? The path was little bit right side shifted. Am I correct or not? Why? Because electric field is left side. Electric field is left side. So all the time the electron will be little bit right of the original path. That means it got shifted to the right, means that is the meaning. இங்க இருக்கிற எலக்ட்ரான் எங்க இருக்கு? கொஞ்சம் முன்னாடி இருக்கு. இங்க இருக்கிற எலக்ட்ரான் கொஞ்சம் முன்னாடி இருக்கு. Which means when electric field is this way, the electron is moving this way. That's what the diagram is showing. The shift is not just in a straight line. The shift is happening in the zigzag. That's when I see the another picture earlier. The electron motion I showed it as a single straight line, right? Now this is the way the electron will be moving. The electron will be moving in this random motion. Clear? While it is coming from one end to another end, it will collide with everybody and it will come. It will collide. It will not come smoothly like this. Is that clear for everybody? Are you able to imagine what is happening? Means, see, actually the electron order limits enna ingandu idu varaku move aganum, limits. Then they did like this zigzag, they reach. Again they will go back like this and all. I didn't show that. But when I applied the electric field, same way, it is performing its original motion only I am indicating. But what happened? Earlier, with no electric field, inge irukkaradu, with electric field little bit this way. This way. Ingadana, you said it's a maximum position, but it went little bit further. That means it moved right. Electron moved right forward. Are you clear with this word? Electron is moved. That's why we said in the presence of electric field, electrons will be drifted. Electrons will be drifted. Hello? Achha. స్టూడెంట్ అయినా వాళ్ళ అర్థం చేస్తారు పార్క్లో చూడమని సార్ గ్రూప్లో మెసేజ్ సార్ గ్రూప్లో పెట్టి okay fine. I hope you understood right here. What you understood, tell me. See, one point you have to. Why, sir, I am giving this detail means there is a chance actually the CBSE physics paper they are asking equivalent to the JE level. Okay, it's not normal CBSE level paper, so they can ask anything. Hello, చెప్పు. సరే సార్ లెఫ్ట్ నాకు స్క్రీన్ షాట్ పంపి నేను చూసి సార్ డ్రెస్ నేను కొంచెం గుర్తుపడతాను. Is that clear for everybody, ma? Purinjicha and the drifting. Okay. So what is came into your mind now? Okay, when electric field is there, the electrons are moving as in the zigzag motion only. But they crossed their limit and went a little bit forward. That's what. They went a little bit forward. Are you clear with that, right? That's why they are going forward. Opposite to the direction of the electric field. Clear for everybody? Yes. So electric field is applied. Okay. I hope it is clear at this diagram. No confusion. Let's see. Take the heading. Derivation of the drift velocity. Derivation of the drift velocity. Derivation of the drift velocity. Now observe. See. Clearly I mentioned. What I mentioned? In the absence of electric field. Electrons are moving here and there. Yes and no. While they are moving, they will be having velocity, right? But when I do the average velocity, that is 0. What is the initial average velocity of all electrons? 0. Because they will cancel out. One is plus V, another is minus V. One is plus 10 means another is minus 10. It will be there. You can find. That's what the meaning. So what is the average of velocity of all the electrons? Initially is 0. That's why no current is there in the conductor. Clear for everybody? So that's what I mentioned in the first. Now when I place them inside the electric field, yes or no? They will face some acceleration, right? Yes or no? Because of that acceleration, initially if it is going with Vi velocity, its velocity will be changed to Vi plus extra, right? Yes or no? What is the formula? V is equal to U plus AT. V is equal to U plus AT. So acceleration is coming. From where that acceleration is coming, ma? Because that electron is experiencing the force. Because that electron experiencing the force. Which electron is experiencing the force? All the electrons will experiencing the force. You are talking about one of the electron. Let me repeat again one more time. The first part is clear, right? What is the first part? When there is no electric field, Vi is equal to Vi average. Individual electron order velocity, is it 0? Very good. Individual electron order velocity is 0? No. Average of them only 0. Clear? Now when I place them, actually I missed one point, that's why you are getting confused. When I place them inside the electric field, they will experience the force. Who will experience the force? Suppose 10 electrons are there. All of us will experience the force of only 1 or 2. Raised fellow, L or okay, all of them will experience the force. Everybody velocity will change. I am studying only one electron. Now I am checking only one electron. Clear for everybody? In the one electron at a velocity, munnadi evalu some V. Ipa evalagu V na plus AT varnum, right? How it is AT, sir? How it is AT, sir? Tell me. Okay, see, let me show you that. See here. So everybody clear? Vi average equal to 0. Correct? Now observe, every electron will experience the force. What is that force? F is equal to ma. Sorry, that force is equal to ma. But what is the force value? It is E into charge. What is the charge? Minus E. Am I correct or not? This E equal to ma. From here, what is the acceleration? Can you tell me? Minus E by m. This is the acceleration for everybody. So even a acceleration same. Even a acceleration same. Correct? Particularly ith ஒரு ith electron நான் பார்க்க போறேன். Which electron I am seeing ma? ஒரு ith electron. And the ith electron oda initial velocity let it be ui. So for my convenience, இது v இல்ல u மாதிரி I am changing. For my convenience, I am changing it to u, initial, right? Like that. ui. This is initial ui. If a final velocity vi will be equal to ui plus what it should be? At. This is the formula that we are having. Vi plus At. So what is the ui? Ui only. Ui is not 0. Average of ui's are 0. Am I correct or not? What is A? Minus E by M into T. Is that clear for everybody? What is this T? This T also special. Observe. One electron in irukka, and the electron, is it moving, right? Move it will go and collide with somebody. Before colliding, see, inga or collision happened. Mudinjichu. Innor collision ஆக போறா. அதுக்கு நடுவுல டைம் இருக்கு, ரைட்? கேப். அந்த டைம் தான் இந்த t. Okay, I will indicate it as like ti. What is ti? Tell me. The time between two successive collisions. What is the ti? Tell me. Time between two successive collisions of that particular electron. Correct? இப்போ நீங்க average பண்ணிக்கோங்க. What do you have to do? Average. That means vi average all and ui average. Inga minus every e is common, m is common. This ti average. Meaning ஒரு எலக்ட்ரானுக்கு அந்த டைம் இருக்கும், ரைட்? பிஃபோர் த கொலிஷன். அது எல்லாம் ஆவரேஜ் பண்ணினா ஒரு ஸ்பெஷல் நேம் இருக்கு, டவ். What is the special name? Special symbol? Tau. இந்த டவோட நேம் என்னன்னா relaxation time. What is the name of that? Relaxation time. What is the name of tau? Relaxation time. What is relaxation time? Average value of the time. What is the time specially? Time between two successive collisions. Average of all that the times is known as relaxation time. Are you clear with that? What is relaxation time? Average of the all the time between two successive collisions. Clear for everybody? Yes or no? Any confusion? Understood, right? Yes. So what you got now? Vi average is equal to, what is the ui average value? Ui average, initially all velocities average will be how much? Can I write 0? No problem. Minus e by m here tau. Correct? Yes or no? This vi average is also known as vd, drift velocity. What is the drift velocity you got? E by m tau. This is the expression for drift velocity. Is that clear, right? So S. How? This name Vi average is nothing but Vd. I wrote in your name. Tejas. I am calling you as Teju. Okay. Any confusion? What is Vd? This is name only Vd. Clear that thing now? Average value only Vd. Yes. Negative, okay. That negative indicates electron is moving opposite to the direction of the electric field. Yes or no? Let's see the slide. In the slide it will be there. Okay, you can write this definition exactly. In the derivation part exactly you can write. Actually I was not able to indicate here one wording. VI symbol I was not able to type properly. So if you need VI is the velocity of the ith electron. Like that some sentence you can use in middle. It is useful. Understand? What is that negative sign indicates? Tell me. Electrons drift in the direction opposite to the electric field. The negative sign is telling that electrons are moving opposite to the direction of the electric field. Clear for everybody? Yes. Fine. Understood? Any confusion? No? Let's see next. Right, mobility. What happened? Derivation you want? Or doubt? I will share this. Okay? I will send this. Fine. Let's see now. I hope you are having one connection from the starting to till now, right? Yes or no? What do you have learned from the beginning? About the conductor, some story we learned, sir. After that, you kept that conductor in the electric field, constant electric. In the electric field changing will not do in this chapter. Electric field change ಆಯ್ತರೆ ಎನ್ನಾಗು unstudy case ವரும். So we said at the beginning, study case. Clear for everybody? Understand? Now see, we want to study next mobility. What is mobility? Okay, see now. Mobility refers to the ease with which mobile charge carriers can move through a material when an electric field is applied. So, how easily the charge carriers can move. That's it. What is mobility meaning? How easily the charge carriers can move when you apply the electric field. If I didn't apply the electric field, they will not move, right? Understand? Clear? See, actually, if you didn't understand the earlier, you cannot make this kind of sentences. What sentences you cannot make? The how easily the charge carriers are moving when you apply the electric field. Yes or no? There is a link, right? That is only nothing but mobility. Who are the charge carriers? In metals, the charge carriers are electrons. In ionized gas, ಹೆಂಗೆ ಇಡುತ್ತುಂದ ionized gas? Anybody? Where we will get ionized gas? Huh? Ange, but not ozone. And the ionosphere. In the ionosphere, they will be in a ionized form. All the gases, whatever are available. Okay? Ionized means nothing. They will be charged. Understand? Normally, இங்க இருக்கிற oxygen கிட்ட charge இருக்காது. அங்க இருக்கிற oxygen இருந்தா charge இருக்கும், that means. Understand? Now, in electrolyte, both positive and negative charges. Now comes to it is essentially a measure of how quickly electrons can travel under the influence of electric force. So mobility ಜಾಸ್ತಿ ಆಗಿರಂದ good, right? Yes or no? Mobility ಕಮ್ಮಿ ಆಗಿರಂದ it's a bad conductor. Understand? Now what is the original definition of mobility? Means magnitude of the drift velocity per unit electric field. So what is that mobility means? Ratio between what? Drift velocity and electric field. Formula only it is. Drift velocity per unit electric field. So Vd per E. What is its SI unit? Meter square per volt second. Meter square per volt second. So what is the final answer for mobility? Mu is equal to E tau by m. E tau by m. Why? Because Vd and E tau E by M, right? E katta. Yes or no? In the VD place lo E tau E by M podunga. Kila E varum. In the E cancel. Then mu is equal to E tau by M only, right? Yes or no? E tau by M only. What is your doubt? Fine. Tell. Mass irukku. Essay. Check properly. Velocity to meter per second. Electric field what it will come? I am using volt per meter. That's why meter square word. See, if you want kg means it should be all changed. See, she got the doubt. What is her doubt means how it is? Meter square per volt. How it is meter square per volt second. Okay, observe carefully. You are having velocity. Velocity and meter per second. Kilo electric field. Electric field units and volt per meter. Engandu vandirukadu? E is equal to V by D. இது ஒரு ஃபார்முலா இருக்கு. ஸோ அங்கந்து இது எவ்வளோ ஆகும்? மீட்டர் ஸ்கொயர் பை வோல்ட் செட். That's understand? Now, is that clear for everybody? Yes or no? Yes. Let's see the next. Right. Relation between drift velocity and current. Relation between drift velocity and current. Relation between drift velocity and current. One of the very, very important one. Relation between drift velocity and current. What happened? Okay, in the drift velocity ku current ku relation kondu varum. So adukkaga na enna edukurenna oru conductor edukuren. What is the length of the conductor? L vechukonga. It will have area, right? Area of cross section A vechukonga. Okay, so what we are doing now? We are connecting we are applying electric field. When you apply electric field only they will move. Am I correct or not? And they apply partner electric field because of the battery. Clear that thing now? And etana free electrons are there in this? Let us assume N are there. N per unit volume. ஒரு யூனிட் வால்யூம் நீங்க எடுத்தா அந்த யூனிட் வால்யூம்ல எத்தனை சார்ஜ் கேரியர்ஸ் ஆர் தேர்? n சார்ஜ் கேரியர்ஸ் ஆர் தேர். ஒரு யூனிட் வால்யூம்ல எத்தனை சார்ஜ் கேரியர்ஸ்? n. சப்போஸ் அப்ப 5 யூனிட் வால்யூம்ல எத்தனை சார்ஜ் கேரியர்ஸ்? 5 into n. கரெக்ட்டா? இப்போ வாட் இஸ் த டோட்டல் வால்யூம் தேர்? ஏரியா ஆஃப் கிராஸ் செக்ஷன் A, length is L, volume is what? V volume is equal to A into L, right? Ipa total how many charge carriers? N into A into L, right? Yes or no? So we have to understand this part. Now observe. Here I am trying to write volume of conductor. What is the volume of conductor? Area into length. Why? Because it is a meter square, it is length. Am I correct? Sir, its length is meter. Meter cube only will get, right? So volume is meter cube only now. So not only that, if you see it as a cylinder, it should be pi r square, its height is h. Pi r square, h only the volume, right? This pi r square is area. This height is length மாதிரி வெச்சுக்கோங்க ai. Okay. இவ்வளவு வால்யூம் இருக்கு. பட் நீங்க என்ன சொன்னாரு? n electrons are there in unit volume, right? So what is the total electrons now? Total electrons, total charge carriers. N into volume. N into volume evolu? Ai. Correct? Ipa total charge evolu? One electron na E charge. Idu mottama electrons, right? That means NaL into E minus NaL E. Correct? But observe properly, Vd is nothing but distance by speed we can write, right? Yes or no? Vd is equal to what? Tell me. Velocity. Distance by speed. Son, velocity formula and normula distance by speed. Sir, distance by time. Distance by time. So from here, distance is L and time is T. L can be written as Vd into, correct? L can be replaced as Vd into T. N into A into Vd into T into E. That is what total charge. Correct? But current is nothing but total charge by time. Correct? NAVD into T into E by time. Time cancel. So what is left out? Tell me. It is nothing but minus NAVDE. I will remember this way, minus NEAVD. That is the current. Understand? This is the expression for your current. Minus NEAVD. Minus NEAVD. Is that clear for everybody? Understand? Fine. Okay? Fine. We'll stop it here. We'll continue in the next class. But try to read up to here in your book. Okay? In next class, we'll see Ohm's law, ohmic substances, non-ohmic substances, resistance, resistivity, and we will see the cells. Okay? We will see the cells. Clear? Adukappuram Kirchhoff law. Clear? Fine. So, but till now, whatever happened, you have to read. Understand? You can leave.